A cylindrical shell 4 meter long and 1.5 meter in diameter is subjected to an internal pressure of 1.4 megapascals. If the thickness of the shell is 12 mm, find the circumferential and longitudinal stresses. Circumferential stress is also known as hoop stress. Find also maximum shear stress and the changes in the dimensions of the cell. Here changes in the dimensions means change in length, change in diameter and change in volume. Okay, now here given Young's modulus E is equal to 205 kilonewton per mm square and Poisson's ratio nu is equal to 0.3. Okay, now so first of all let us write given data. A cylindrical shell 4 meter long, so length of the cylinder is 4 meters, so L is equal to 4 meters. So here L is equal to 4 meters, so we have to convert all dimensions. Here I am going to convert all the dimensions into millimeters. Here meters is given. We know that 1 meter is equal to 1000 millimeters. So 4 meters becomes 4000 millimeters. 4 into 1000, 4000. And internal diameter D given 1.5 meters. Let us convert meters into mm and multiply with 10 cubes, then 1.5 into 10 cube mm and 1500 mm. Internal pressure given 1.4 megapascal, and remember 1 megapascal is equal to 1 newton per mm square. 1 megapascal is equal to 1 newton per mm square or 10 power 6 pascal. 10 power 6 pascal. Okay, so pascal means newton per meter square. Okay, so anyhow next thickness. So thickness is given 12 mm thickness. And next given Young's modulus E is equal to 205 kilo newton per mm square. Let us convert it into newton per mm square. Kilo means 10 to the 10 cube, so 205 into 10 cube newton per mm square. And next given Poisson's ratio, nu is equal to how much given 0.3. Poisson's ratio nu is equal to 0.3. Okay, so let us find stresses. So first circumferential stress, or also known as hoop stress. Circumferential stress or hoop stress, so generally denoted by sigma h. So circumferential stress or hoop stress, sigma h is equal to, in case of thin cylinder, sigma h or sigma c is equal to PD by PID by 2T. Here Pi means internal pressure. Here internal pressure is 1.4 newton per mm square into diameter. Here diameter is 1500 mm by 2T. 2 into thickness of the shell is 12 mm. So hoop stress units newton per mm square. So let us simplify this. Sigma h is equals to, okay, so here 1.4 into 1500 by 2 12s are 24. So 1.4 into 1500. So I got 2100. So 2100 by 24. 2100 divided by 24. Okay, you will get 87.5 megapascals, 87 or newton per mm square, So this is the circumferential stress experienced by the thin cylinder. Next we need longitudinal stress. So longitudinal stress denoted by sigma L. So longitudinal stress sigma L is equal to actually PD by PID by 2T. PD by 2T or PID by 2T. So PD by 40. PD by 40. So longitudinal stress sigma L is equal to PD by 40. Or it can also be written as off of hoop stress. Okay now, so sigma L is equal to, you're already off of hoop stress is already calculated. How much? 87.5 MPa. 87.5 MPa. Okay now, so off of 87.5 MPa divided by 2, you will get 43.75 MPa. 43.75 MPa megapascal. So this is longitudinal stress. సో ఊప్ స్ట్రెస్లో ఆఫ్ ఏమవుతుందంటే లాంగిట్యూనల్ స్ట్రెస్ అవుతుంది యాక్చువల్గా. ఓకేనా, సో ఊప్ స్ట్రెస్ ఏమో 87.5, లాంగిట్యూనల్ స్ట్రెస్ ఏమో 43.75 MPa. నెక్స్ట్ వీ నీడ్ టు ఫైండ్ షియర్ స్ట్రెస్, maximum shear stress. Next we need maximum shear stress. So tau max denoted by tau max. Maximum shear stress is equals to pi d by 80. This is the formula for maximum shear stress. So PID, so pressure, internal pressure 1.4 and the diameter is 1500 by, so we have 8 into thickness 12 mm. Okay, so let's solve this. So tau max is equals to 1.4 into 1500, 2100 by 8 12s are 96. So 2100 by 96. 2100 by 96. So you will get 21.875. 21.875 MPa megapascals. This is maximum shear stress. Okay, next we need to find strains, change in dimensions, I mean. Okay, so next let us find change in length of the cylinder. Change in length, so change in length denoted by delta L. So how do we get delta L? We have a formula. Okay now, delta L is equal to change in length is equal to PD by 4TE into 2 minus nu into L. This is the formula for change in length of a thin cylinder. So change in length of thin cylinder, delta L is equal to PD by 4TE into 2 minus nu into L, where L is length of the cylinder, nu is Poisson's ratio, E is Young's modulus and T is thickness, and P is internal pressure and D is diameter of a cylinder. Let us substitute all the values. Delta L is equal to, so here internal pressure how much again? 1.4 into diameter 1500 by 4 into thickness 12 mm and Young's modulus 205 into 10 cube into 2 minus Poisson's ratio how much again? 0.3 into length of the cylinder. Here length of the cylinder is 4000 mm. So let us so length of the cylinder is 4000 mm. Okay now, so let us calculate the value of this. L is equal to, so 1.4 into and 1500 by 4 into 12 into 205 into 10 cube. Okay now, PD by 40 into 2 minus 0.3 1.7 into, so length of the cylinder 4000. Okay now let us calculate numerator value. 1.4 into 1500 into 1.7 into 4000, so you will get 14280,000 14280,000 by, and denominator value 4 into 12 48 into 205 into 1000, 9840,000 9840,000 mm. Change in length units mm. So let us divide 14,280,000 by 9, you will get 1.451. Change in length is equal to 1.4512 mm. This is change in length of this cylinder. Okay, next let us find next change in diameter. So change in diameter find out chedam. So change in diameter of a cylinder denoted by delta D. So change in diameter formula, delta D is equal to PD by 4TE. Okay, PD by 4TE into 1 minus 2 nu into D. Okay, now this is the formula for change in diameter, or in simplest form we can written as PD into D square, PD square by 4TE into 1 minus 2 nu. So this is the formula for change in diameter of a thin cylinder. So now substitute all the values here. Delta D is equal to, so here what is the value of pressure? 1.4 into diameter 1500, so 1500 whole square into 1 minus 2 into nu value 0.3 whole divided by 4 into thickness 12 mm into Young's modulus 205 into 10 cube. Okay, so delta D is equal to 1.4 into 1500 whole square into 1 minus 2 into 0.3 0.6 by 4 12s are 48 into 205 into 10 cube. Okay, now let's calculate the value of as usual. First of all, let us find value of numerator and afterwards denominator. Anyhow, your units is mm. Change in diameter units mm lo untundi. Okay, na? So let us find the value. So numerator 1.4 into 1500 whole square into 1 minus 0.6 0.4. Okay, one 260,000 divided by, so denominator 9840,000. So the value is 9840,000. 0.128 mm. Change in diameter is 0.128 mm. This is change in diameter of a cylinder. So at last we need change in volume. Question, change in volume. So delta V denoted by delta V. We need change in volume. So change in volume, delta V is equal to formula PD by as usual PD by 4TE into 5 minus 2 nu into V, where V is original volume of the cylinder, initial volume of the cylinder. So first of all let us find the volume of the cylinder. Volume of cylinder, here V means volume of a cylinder. Volume of a cylinder. Volume of a cylinder V is equal to pi by 4 into d square into L. So pi by 4 into d square. Here diameter how much given? Given diameter is 1500. 1500 whole square into L means length of the cylinder 4000. Okay. So okay, let us substitute this values here. This value here. So delta V is equal to pressure 1.4 and diameter 1500 by 4 into thickness 12 mm into Young's modulus 205 into 10 cube. Okay, into 5 minus 2 nu means nu value 0.3 Poisson's ratio into volume. Here volume is pi by 4 into 1500 whole square into 4000. So We have to simplify this to get the final answer. Anyhow, okay, now here 4 into 12 into 205 into 10 cube, as usual, you know the answer 9840000. We need to simplify this, so including this denominator 4. So 1.4 into 1500, 2 into 0.3, 0.6, 5 minus 0.6, 4.4, 4.4 into shift pi into 1500 whole square into 4000 whole divided by 4. So you will get 6.53137 into 10 power 13 whole divided by, so 48 into 205 into 10 cube, or you can write 9. So you will get delta V as, you know here unit is mm cube. You will get delta V as 6637572 0.28 mm cube. We know that 1 mm cube is equals to 10 power minus 3 centimeter cube. So therefore change in volume in centimeter cube is, cubic centimeters is 6637 point approximately 6 centimeter cube. Okay, no? So we have to move this point to here. Okay, 3 places because 10 power minus 3. This is change in volume of the thin cylinder. Okay, na 6637.6 centimeter cube.